Freeform is a powerful feature that industrial designers and anyone with a need to design ergonomic, freeform shapes will be glad that SolidWorks includes. This feature allows you to push and pull on a surface to create complex shapes that are otherwise difficult to produce. Freeform can be applied to any face. The face can belong to a surface or to a solid part. Let's take a look at an example. Here we have a surface. The Freeform feature is located on the Surfaces toolbar. I'll click on it, and this brings up the Freeform Property Manager. You can see there are many options and settings available. But before stepping through each one in detail, let me explain the basics of the Freeform feature. First, we'll identify a face. In order to push and pull on the face, we need to add control points. However, these points cannot be added to the face randomly. They must be created along control curves. This sets up our basic procedure. Identify a face, create control curves, create control points, then push and pull. Now let's run through this procedure. I'll begin by selecting the face, and SolidWorks then creates a mesh or a grid on the face. These will come into play in a moment. Each of the four sides of the face will also have a continuity callout. This setting controls how the boundaries of the face will behave. Options here are contact, tangent, curvature, movable, and movable tangent. With the exception of movable, these settings behave exactly as you would expect. Movable is interesting because it allows you to modify a face by actually changing its boundary edge. I'll set one boundary to movable. Notice when I arrive at the movable setting, the Add Control Points button in the Feature Manager is activated. This is because the movable setting automatically treats the boundary edge as a control curve. I can now click the Add Points button and click along the edge to create control points. I'll use 2 control points in this case. As soon as my second point is created, my pointer will offer a shortcut allowing me to right-click and finish the point creation process. However, if I move the pointer, the right-click shortcut will disappear. To exit out of the point creation mode, I can either click the Add Points button again, right-click and select Add Points from the pop-up menu, or press the Escape key on the keyboard. You'll know you've exited point creation mode when your pointer returns to the standard selection arrow. Now that control points have been created, I'll select the control curve. In this case, the boundary edge, to reveal the control points and tangency control arrows. When a point is selected, a reference triad appears. You can use this to push and pull on the surface. The triad will help you control direction, or you can drag the center of the triad for free three-dimensional movement. The behavior of the triad can be controlled using the options in the Property Manager. It can be orientated based on the global coordinate system, the surface, or the control curve. You can also have the triad move as you move the control point. If you were to clear the Triad Follow selection option, the triad would remain in place. In addition to moving the control points themselves, you can also affect the ends of the boundary edge by dragging the tangency arrows. This will affect the transition from the ends of the edge to the deformed shape. So far, we've affected the shape of this face using control points created directly on the boundary edge. Remember, though, that we only had the ability to create these points because of the movable continuity setting we specified. In fact, if I click the continuity callout and change it to contact, all modifications are lost. In the next lesson, we'll take a look at how curves can be used to gain more control over the resulting shape of this face.